Example 8 says, how much more money will you earn if you invest $10,000 for 15 years at 8% compounded continuously instead of 8% compounded quarterly? So we're going to have to calculate two different scenarios. There is the continuously compounded, and then there is the quarterly. Oof. Spelling is a struggle for me. Okay, quarterly compounded. Okay, so S is equal to P times E to the power of RT, and we know that the initial amount is 10,000 E, and the interest rate is 0.08 times 15 years. So if we throw that into our calculator, we should get $33,201.17, and the formula for regularly compounded interest is S equals P times 1 plus R over M to the power of MT. So that is going to equal 10,000 times 1 plus our interest rate is 8%, and we are compounding 4 times per year for 15 years. And if we throw that into our calculator, we get that S is approximately $32,810.31. And if we subtract those values, because we want to see the difference, that difference is equal to $390.86. So that is how much more money you are making if you have continuously compounded interest versus quarterly compounded interest. Let's move on to example 9. It says, how long will it take an investment of $10,000 to double if it is invested at 8% compounded continuously? So we know that we want our investment to double, so we want the future value to be 20,000. Our starting value is 10,000. We have E times, to the power of 0.08, and the number of years is the thing that we're solving for. So I'm going to divide both sides by 10,000 to start off with, and the left-hand side will simplify to 2, and then I'll have E to the power of 0.08t. Now, this is where we're going to have to utilize techniques from last section. We know that the variable that we are solving for is in the exponent. That means that we're going to have to utilize logarithms. I am going to take the natural log of both sides. And the reason that helps us is because we know that the power rule for logarithms allows us to take the exponent on the outside and multiply it like that. Now, hopefully you remember from the last unit that the natural log of E is just 1. If you don't recall that, think about it for a minute as to why that is. And I'm trying to solve for t, so I'm going to divide this equation on both sides by 0.08. So we get that t is approximately, if you throw that into your calculator, about 8.66 years. So that is how long it will take for our investment to double.